This is example 4.10, which is taken from your textbooks. A 10 kilowatt, 100 volts, 1000 RPM DC machine has 0.1 ohm of armature resistance and is connected to a 100 volts DC supply. Part A. Determine the starting current if no starting resistance is used in the armature circuit. So let's draw the armature circuit first for part A. During the startup, omega is equal to 0, which means that EA is equals to K phi omega, which is going to be equals to 0. Therefore, if we take the KVL around this loop, then we can calculate the current. IA equals to 100 over 0.1, which is equals to 1000 ampere. This is very large because, as you can see that from the question, the power ratings of the machines is 10 kilowatt and the voltage rating is 100 volts, which means that the rating of the current is 100 ampere. So 1000 ampere is 10 times higher than the rated current. Part B. Determine the value of the starting resistance if the starting current is limited to twice the rated current. So twice the rated current is 200 ampere because the rated current is 100 ampere, which is 10,000 divided with 100. So we want the starting current to be limited to 200 ampere. With the external or with the starter resistance inserted in the armature circuit, okay, during the startup, again EA is going to be equals to 0. We want to limit the armature current to 200 ampere during the startup. And this must be equal to 200. Therefore, you can calculate the values of starter resistor as equals to 0.4 ohm. Part C of the question asks us to find the values of the resistances required in the starter box such that the armature current IA is constrained within 100, which is 100 ampere, to 200 or 200 ampere of its rated value during startup. So let's do part C now. So the circuit for part C is going to consist of the starter box, which consists of the variable resistance. So we need to determine the values of the resistances in the starter box such that whenever we change the positions of the wiper of the starter box resistor, the armature current is limited to 100%, which is 100 ampere, to 200% or 200 ampere of the armature current. So if we draw the armature current graph, the armature current has to be limited within 200 and 100 ampere. Okay, so at startup, in which EA is equal to 0, we have already calculated the values of the RST, which is equals to 0.4 ohm. Then, as we have seen earlier, the speed starts to build up. So too is going to be the back MF, which is going to build up from 0 to a new value. As EA builds up, then the current reduces. When the current reaches 100 ampere, then we will change the positions of the wiper so that we have a new value of RST. The question is, what is going to be that value of RST? So let me write it down first here. At T equals to 0, then the armature current is equals to 200 ampere and RST is equals to 0.4 ohm as we have calculated before. So at T equals to 0, I call that RST0 is equals to 0.4 ohm. So as speed builds up, then EA will also increase, which will cause armature current to reduce, which we have seen before in the previous slide, okay, which is governed by this equation here. When IA equals to 100 ampere, let's call that T1. And let's call that RST1. Therefore, we need to find the new value of RST, which is we call that RST1, so that the current will increase back to 200 ampere, which means that at T1, as we change the positions of the wiper, then the current will rise back to 200 ampere. So the question is, what is going to be the values of RST1? If we write down the KVL around this armature circuit, which gives EA. Now, at T equals to T1 minus, which is just before RST is reduced, just before RST1, we know that IA is still equals to 100 ampere. So from here, we can write down the equations of the back EMF voltage EA as equals to 0.1 plus 0. Just before the wiper is changed to a new position, the value of the starter resistor or starter resistance is 0.4, and 0.1 is the resistance of the armature winding. So from there we can obtain the values of the back EMF just before RST1, which is 50 volts. At T equals to T1 plus, okay, which is just after RST1, which is the new value of the resistance, I can write down that the back EMF is still going to be 50 volts, but the current now is 200 ampere, and RST is going to be equal to RST1. If you recall that before and after the switch is moved to a new position, the speed as well as the back EMF is going to be the same. Okay, so 50 volt here is before RST1, and 50 volt here is just after RST1, which means that from here you can calculate the values of RST1 as equals to 50 over 200 minus 0.1, which is equals to 0.15 ohm. So new values of the starter resistance is 0.15 ohm to limit the current to 200 ampere. And the speed is going to build up, and as the speed builds up, the current will again reduces until it reaches the values of 100 ampere, and then we change again the positions of the wiper, and we need to find the values of the starter resistance in order to limit the current to 200 ampere. And we are going to call that as T1 here, sorry, T2. So at T equals to T2 minus, which is just before T2, RST is still equals to 0.15. And from there we can calculate the values of EA. So EA is equals to, okay, now EA is equals to 75 volts because the speed has built up from the previous value of 50 volts. Now it is becoming 75 volts. At T equals to T2 plus, which is just after the wiper sweeps or changes to a new position, the back EMF voltage is still going to be at 75 volts. But the current now changes to 200 ampere, which is that value there. And from there, we can find the values of RST2. And the speed will build up, and the current will again reduces to 200 ampere, sorry, to 100 ampere. And again, when it reaches 100 ampere, we will switch the wiper to a new positions, and we have to calculate the values of RST3 so that the current rise back to 200 ampere. So I'm going to call this as T3. So at T equals to T3 minus, which is just before RST3, okay, so the back EMF increases from 75 volts to 87.5 at T3. After a new positions of the wiper, the back EMF is still going to be the same as before, which is 87.5. However, the current increases to 200 ampere, which is that point there. So if you calculate the values of RST, that gives a negative value of 0.0375. So what happened? Which means that at T equals to T3 plus, the current does not reach 200 ampere. In fact, we don't need RST3, because if RST3 is equals to 0, then the values of the armature current is still within the range of 100 and 200 ampere. So with a 0 RST3, then IA is equals to 100 minus 87.5 over 0.1, which is equals to 125 ampere, which is still in the limit of 100 and 200 ampere, which means that we need to change this graph. Instead of going to 200 now, it is going to be 125, which is probably somewhere there. And the speed will build up, and the current will finally eventually settle down to a steady state value. Okay, so the starter resistance or the starter box is going to consist of these values of the resistances that we have calculated. Initially, the value of resistance is going to be 0.4 ohm, and then a new position here, the value of the resistance is going to be equals to 0.15, and here the value of resistance is going to be equals to 0.025, which means that our resistance starter boxes will consist of 0.025 ohms, and then 0.125 and 0.25, which is basically the difference between 0 and 4, and 0.15 is 0.125, and the difference between 0.025 and 0.15 is 0.025. So the wiper is going to sweep between these values starting from here, and then it will sweep to a new value here, and then it will go to the new value here, and eventually RST is going to be equals to 0. So that completes example 4.10.